In this chapter, I'm going to explain version control. If you are serious about getting into the DevOps mindset, version control is really the first thing you should master. You will be using version control every day in your life as a software engineer or even as a system administrator when you are applying DevOps techniques. I have a system administrator background and I'm using version control every day, even for the contents of this course. Let's go over the definition of version control. Version control, also known as revision control or source control, is the management of changes to documents, computer programs, large websites, and other collections of information. In our context, this means that we will store all our code in a version control system. Previously, we would use technologies like CVS or Subversion, but nowadays everyone uses Git. Git is a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. It was initially designed and developed by Linus Torvalds. He developed it to use as a version control system for the Linux kernel. Let's have a closer look. It's free, it's open source, it's also distributed, so it doesn't just sit on one server or on one client, and it also is designed for speed and efficiency. So it will work for small projects, but also for very large projects, like the Linux kernel, for instance. Developers will use version control as a golden source for software, but also operations will use it for automation. Operations team will use it to store scripts, tools, and software configuration. So it's not just a tool for developers. As a system administrator, you will also need to understand how to use version control. Git is a distributed version control, but what does that even mean? You now see a picture of a repository and 3 developers. Distributed means that our Git repository will not be saved in one place. Every developer has a copy of the full repository. It's called a clone. This makes the probability of losing data really small. Most of the developers will use a central repository, like GitHub or Bitbucket. When using a central repository, developers will push their local changes to the central server and also pull new changes from teammates from the server. Let's take a look at how we make changes to our code. As a developer, you can make some local changes. Let's say you have changed a few lines in a file to fix a bug. Now, what you need to do is to commit those changes locally by using git commit. Commit will add the changes to your local branch, which is by default the master branch, as you see on the image on the left. This commit is still only local, and you see that your local master branch is now ahead of the original master branch called origin master, which is the remote master branch. To share those changes with your team, use git push to send your changes to the central repository. Now take a look at the bottom left picture. You see that the remote master, shown as origin, has caught up with your local master branch. Your local changes are now saved in the central repository server. Now that we pushed our changes to the central repository, other team members can retrieve the changes by using git pull. You can see on the image that our team member has an outdated version of our repository. When executing git pull, it will fetch the changes from the central repository and merge the remote changes with our local branch. On the left bottom picture, you see that our master branch is now pointing to the last commit, the same commit that was pushed earlier by another developer. Git is a really powerful tool and very complex to fully understand. It will take you some time to get used to. Another feature that is widely used in Git are branches. Developers can work on their own feature branch so they don't disturb anyone else, which is also implementing certain features. You see on the diagram here that we have our master branch in blue, a little feature branch in purple, and a big feature branch that has multiple commits in green. At some point, these branches will need to be merged back into the master branch, which will bring us to merging. After a feature is finished, the branch can be merged, and at that point, code conflicts will need to be resolved. Let's say that 2 developers changed the same line of code. You have a conflict that would need to be resolved. This is often done manually and can take a lot of work. Merging happens with the command git merge. On the top left picture, you see the implementation of some feature in a separate branch. And in the picture below, you see what happens when we use git merge to merge it back into the master branch. Now it's time to talk about best practices. The Git flow workflow defines a strict branching model designed around the project release. It basically forces every developer to use a feature branch, which is in green in the picture. Once a developer finishes working on the feature branch, he'll merge it with a branch called develop. Then, when the team wants to do release, they will prepare a release and merge develop back in master. You can also have intermediate hotfixes that branch from the master branch. The Git flow workflow makes working with Git a lot cleaner, and there are a lot of companies adopting this workflow. This is a very high-level overview. If you want to know more, check the link provided in the notes of this course. Here are some tools you can use to work with Git. A lot of people also use Git implementations that come with their IDE, like with Eclipse or with IntelliJ. Myself, I often work with command line, and then I use some extra tools to do merging when I have a conflict. In a demo that comes next, we will explore some of the commands that I explained in this section.